Okay, so good afternoon, everyone. And now, today we will start our next part of the distribution or statistical part. First of all, today we are going to discuss about first topic is binomial distribution. So, any of you have anything sort of knowledge like binomial distribution? What is it and what is likely to be done? Any of you know what is the binomial distribution actually? Just sort of description or definition you can give. Have you any prior knowledge about binomial distribution, or you have already heard that term? You can write down in the chat box also, or you can unmute. Anybody don't know or don't hear about the term binomial distribution? Hello, hello, please respond. Anybody? Am I audible to guys? Gayatri, Sandeep.
Yes, sir.
Okay. Just asking, have you any heard about binomial distribution? Okay, so let's start the binomial distribution. I think somebody or for many of you, those who are present here don't have a sort of think like, so just think about binomial distribution. We are thoroughly discuss about what is it and where it is used for Python, for calculation, for all the things. As I already mentioned you guys that for data analyst and furthermore for data science, the main thing is mathematical calculation. You have a mediocre to advanced level of problem solving skill. Okay. So first of the thing is, suppose there are result in our daily life, there are so much circumstances or so much incident like uh, what can I say, like two answers, only two result will come. Is it yes or no, or success or failure? So that type of incident in our circumstances is happen. That type of there we can assure like binomial distribution. Okay. Whenever we toss in a game, it's supposed to be heads or tails. Heads or tails. So there likely it will be binomial distribution also. Another thing will be if a boy is get any marks, a boy or girl, any student can get any marks like 80%, 70%, 30%, 40%, 60%, but the final result, is it passed or failed, to depend upon two result, pass or fail. So here we can also use binomial distribution. Other case, uh, when you throw a dice, when you play Ludo, when you throw a dice, there will be like 1, 2, 3, 4, 5, 6. 6 outcomes you can get. Okay. So just like this type of things in a dice, you can hear. So this thing 1, 2, 3, 4, 5, and 6. So there are 6 sides are there. So 6 sides will be thrown as a dice. 1, 2, 3, 4, 5, 6. What is the chance or what is the probability of getting 1 or getting 2 or getting 3 or getting 4? Okay. The probability of getting 2 is 1 by 6. Why it is 1 by 6? 6, only 6 answers you can get from that. 6 answers you can get. You can't be get 7 or greater or is equal to 7. You can't get from a dice. You can only get 1 to 6. So 2, when you throw a dice, first chance, at a first chance, we can get 2. The probability is 1 by 6. We can get only 1, 2. Similarly, we can get only 1, 3, only 1, 4, only 1, 5, only 1, 6. The first time when you throw a die. Okay. So this is the portion, or this is the things where we can use the binomial distribution function or binomial distribution method. So if there will be like definition, what is the definition of binomial distribution? In probability theory and statistics, the binomial distribution is the discrete probability distribution that gives only two possible results. In an experiment, either it would be success or failure. Okay. In an experiment, when you done probability, such type of experiment is getting only two types of result. Either it is yes or no, either it is success or failure, either it is happened or not happened. Either or, just only two random experiment will be there. That type of things mostly we are using binomial distribution. In spite of that, just like example, for example, if we toss a coin, there could be only two possible outcomes, head or tail. If head, there will be first batting, means success. If will be tail, then opponent will be win, means failure. Just like that. If any test is taken, that there could be only two result, pass or fail. The student get greater than 30 marks, greater or is equal to 30 marks, it means it is passed. If it is get less than 30 marks, it is means fail. Only two results. It is not a draw. Any draw is not happening. Draw, abandon, this type of not here. Pass or fail, heads or tails, success or failure. So this type of distribution is called binomial probability distribution, or you can say binomial distribution. Clear, everyone? What is the definition of binomial distribution?
Yes, sir.
Venkatesh, Pallavi, Gayatri, Mehul, clear?
Yes.
Okay. Now the thing is, there are two parameters mainly used for binomial distribution. For binomial distribution, two parameters. One is n, p is another is p. N is number of times you occur the experiments, or you happened the experiments, number of times. P is the probability. P is the probability and n is the number of times that the experiment is occurred. Suppose a die is thrown randomly 10 times. Okay. Then the probability of getting 2 for any one time. First time you just throwing it, and the chances of getting 2 is 1 by 6. Not just 2. As I mentioned, 1 to 6. Any of the number is getting for any one time chance, the probability is 1 by 6. So when you throw the dice 10 times, you have a binomial distribution of n number of time that the performance or the experiment occurred 10 times, and p is the probability of each time 1 by 6. So now these type of things will be there. You can learn the formula and then you just use it for your calculation in the further experimental work. Okay. Now, next part. So binomial distribution, in binomial probability distribution, the number of success in a sequence of n experiment where each time a question is asked for yes or no. In binomial probability distribution, think about very carefully. In binomial probability distribution, the number of success in a sequence of n experiments where each time a question is asked for yes or no, then the Boolean value outcome is represented either with success or yes or true or one. that is the probability P, or failure, no, false, zero probability. This probability is denoted with Q, that is 1 minus P. So that means success probability denotes with P. Then it will like failure, whatever it failure, or like zero, false, no, this type of probability we denote with Q. That means, and we obviously know the sum of the probabilities are 1 in the previous class. So that means Q is equal to 1 minus P, or P is equal to 1 minus Q. Okay. Now, this a single success or failure is called Bernoulli's trial. Okay. A single success or failure is called Bernoulli's trial. Okay. A series of outcome means a series of probability. A series of outcomes means a series of probability is called Bernoulli's process. A series of probability is called Bernoulli's process. Okay. So these things are there. Now the next part is for n is equal to 1, that is a single experiment, means the performance, the experiment happened for one time. That is a single experiment. The binomial distribution is a binomial Bernoulli's distribution. Okay. The binomial distribution is the base for the famous binomial test of statistical importance. There are hypothesis testing, binomial testing, all the things are there. So binomial testing is based upon binomial probability distribution. When there will be performance occurred for one time, it is called Bernoulli's distribution. 1 minute, guys. Sorry, guys. Okay, so for n is equal to 1, that means when the performance occurred for a one time, then that is a single experiment. The binomial distribution is for Bernoulli's distribution, and it will be based from a famous Bernoulli or binomial testing that is happened for statistical report. It will be based upon the binomial distribution. Okay. Now we are moving on to the examples. I think everyone clear with it how actually binomial distribution, binomial term is happened. I think it is very much clear to all of you. Now, giving for more of it like example, because we are covering with theoretical portion, graphical portion, then Numpy module also for a single distribution, single statistical report. So binomial distribution example, as we already know, binomial distribution gives the possibility of different set of outcomes. Okay. In real life, the concept is used for success, you can see, or failure. Okay. Like finding the quantity of a raw used material while making a product. Suppose you are making a product like paper or like anything about steel. Okay. Just a second, guys. Okay, sorry guys. Binomial distribution, where we can use it, like this type of example we are discussing. So, like raw material, is there raw material or used material, like making of paper or steel? In every factory, we can also see that finding the quantity of raw material and used materials while making a product. Then there will be like taking a survey of positive and negative reviews from the public for any specific product or place. Positive and negative reviews. By using yes or no survey, we can check whether the number of the persons views the particular channel. By using the yes or no survey, we can check whether the number of the persons views of the particular channel. To find the number of male and female employees in an organization, the number of votes collected by a candidate. Election, yes, obviously there are, suppose uh, how the voting is done in election. There will be like two members that are standing different party, and we have to donate, we have to give voting for them. So like A or B, when you suppose press a voting, this is the suppose like voting ballot. When you post a vote, suppose A and B, you are there. So when you press A, so that means it will be 1 and then 0. When you press B, then it will be 0, 1. So that's how actually election voting systems in the mechanism of the stool. Okay, you can say the mechanism of the device actually work. So these things are for binomial distribution we can use, or for the daily life, it actually use day by day. Okay. Now suppose some properties of the binomial distribution. The properties of binomial distribution are, there are two possible outcomes, true or false, success or failure, yes or no, as I already discussed. Two possible outcomes only in the binomial distribution. There is n number of independent trial or a fixed number of n times repeated trial. There is n number of independent trials or a fixed number of n times repeated trials present in the binomial distribution. The probability of success or failure remains the same for each trial. Only the number of success is calculated out of independent trial. Every trial is independent trial, which means the outcome of one trial does not affect the outcome of another trial. Okay, now discuss about the properties. What are actually these 5 lines tell? There are two possible outcomes, true or false, success or failure, yes or no. For binomial distribution, as I already mentioned, there will be like, if these things will be denoted into data of computerized data, okay, then it will be like 1 or 0. If there is success, there is true, there is yes, that is 1. If there is false, failure or no, there is 0. So it is computerized language. Okay, this thing means. So number 1 done. There is n number of independent trials or a fixed number of n times repeated trials. Okay, and there is n number of independent trial. Like you can choose 10 times, 10 times of a coin. There will be two fixed results. Okay, that is the fixed number of n times repeated trial. A fixed number of n times repeated trial. Okay, and n number of independent trial. How many types of you throw a dice? You can get 1, 2, 3, 4, 5, 6. But in the tossing, you can get also, actually die also in the fixed number, because you only get 1 to 6, and then for tossing you only get head or tail. But 10 times you do repeated time, there are not nothing like specially mentioned how many times you have to be done. So only get yes or no, success or failure answer. So that is, you can get the n number of independent or a fixed number of n dependent trials. Number 3, the probability of success or failure remains the same for each trial. Means, suppose if you toss a coin, head or tail, if you toss a coin, if you toss a coin for the any one time, first time, there will be like Sandeep is there and Mehul is there. Two times Sandeep called for head. So when the coin jump and then got down in the ground, suppose there will be head. So that means success. Okay. But as well as Mehul get the failure. That means for each trial, for each same trial, probability of success or failure remains the same. I think you can understand what I am trying to say. You just suppose throw a dice of 2 and you asked like what is the probability of coming in this trial, then coming the number of 3. If 3 comes, that is success. If 3 does not come, means that is failure. If 3 comes, that is success for 3, but as well as the others numbers are coming, that is failure. So same success or failure remains the same for each trial. Only the number of success is calculated out of n independent trials. Like 10, it's nothing but dependent. It is you can just tossing a coin and how many times it is success, whatever you called, not just tossing coin, you just getting anything like raw material thing, positive, negative feedback. How many times you getting the success is calculated in independent trials upon that. And the last is every trial is an independent trial, which means the outcome of one trial not affect the outcome of another trial. That means if anyone like there will be one toss in a match, okay, one toss in a match. If you coin, you jumped the coin, head comes upon, okay, that head comes upon in an trial or in an coin tossing, it does not affect if in the second match there you toss a coin and get tail. There is no way like in the previous match you can get tail head, so in this match you can get tail. So suppose there is a new rule that you are not getting to bat, just not like that. Okay, so tossing a coin or positive or negative, suppose there is a positive feedback of a product, two positive feedback of a product and one negative feedback of a product, or you can say repeated time two negative feedback of a product, and same product after modification next month you can get a positive feedback. So that does not mean that that last positive feedback will be affected of the previous two feedback negative feedback, or this present tossing a coin and getting head does not affect on the next match you tossing a coin and getting tail. So every trial is an independent, and that means outcome of one trial does not affect the outcome of another trial. That is binomial distribution trials are all independent. Clear everyone? What is the properties of it? Clear? Anyone have
Yes,
any
sir.
question?
No, sir.
Okay. Now, what is the formula? There is a little bit of permutation and combination is manageable there. Binomial distribution formula, like the binomial distribution formula is for any random variable x given by, very much carefully see, the binomial distribution formula is for any random variable x given by p is the probability, okay, x is the random variable, and n is the time for p is actually, it is not small p, it is capital P, because it is denote the probability, the answer. Okay, x colon n is the times of trial and p is the probability that is comes for each trial. So that is n c x. then px 1 minus p, okay, then to the power n minus x, or you can write it like that way, n c x p x 1 minus p means q to the power n minus x. So that is the rules of binomial distribution of probability. N C X P X 1 minus P means Q N minus X. This is the rule. Okay. Where N is the number of experiment or number of trial, whatever it like. N is the number of experiment, N is the number of trial. Okay. X is the random variable 0, 1, 2, 3, 4, 5. Whenever we are using the example, it is like theoretical or formula. Whenever we jumped upon the real example, then you can get more for this type of formula. P, capital P, sorry, small p is the probability of success in a single experiment. This small p is the success of this is a number of probability of success in a single experiment, and this q or p 1 minus p, that means it is the number of failure of number of probability of failure in a single experiment. So the binomial distribution formula can be also written in the n binomial trial. Also you can write in Bernoulli trial, where just a second, n c x is equal to n factorial by x factorial n minus x factorial. N x factorial means n into n minus 1 into n minus 2 dot 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 dot. X factorials means x into x minus 1 into x minus 2, like that way. Okay. Whatever you understand, it's upon you how you can remind it. Okay. So this is actually the rules of Bernoulli's trial. This rule, NCX is equal to n factorial x factorial n minus x factorial. If we conjugate these two rules, so the new rule comes upon p x colon small n small p. NCX means n factorial by x factorial into n minus x factorial. Then px q or 1 minus p to the power n minus x. Okay. So this is the probability. This is the main formula, binomial distribution. This is called Bernoulli's trial formula. If binomial distribution and Bernoulli's trial conjugate with each other, we can get this formula. Clear? Any of you have any question about the formula? How can it will be used for the example we will discuss? It is not p to the power x. It is like p here x. NCX means n factorial by x factorial into x minus x factorial. That means px means p factorial by x factorial into p minus x factorial. Now p factorial means p into p minus 1 into p minus 2 into p minus 3. Means if you want to find 5 factorial, That means 5 into 4 into 3 into 2 into 1. In that way, it will decrease the number. If there is 3 factorial, just like 3 into 2 into 1. So NCX means n factorial by x factorial into n minus x factorial. So they are like px, not into. It is p, and in the bottom of p, in corner way, you can write x. Px, that means p factorial by x factorial into p minus x factorial. Okay. So this is the rule. Clear, Mehul? Okay. You please note the rule. Little bit of mathematical terms are there, because obviously, see, visualization, coding, already we know all the things we'll know. It is very much important to problem solving. Actually, data analyst is more of our calculation portion is there. So much calculation. Okay, how we can prepare, what type of things are there, what type of things we can represent it. So can be demonstrate in a mathematical terms also. After mathematical terms done, then you can perform it into the like the way that can visualize it or anything like that. Okay, please note the formula, then we can move on for the next part. Done, everyone? Write down in the chat box. Everyone done with it? Gayatri, Mehul, Pallavi, Venkatesh.
Yes, sir.
Okay. So let's jump to the example. Okay. There is a question that the question is binomial distribution example. If a coin is tossed 5 times, find the probability of exactly 2 head. If a coin tossed 2 times, means n is, sorry, tossed 5 times means n is equal to 5. So whenever give you the information, just read. So the the coin tossed 5 times, n is 5. Now for exactly 2 heads, that means x is equal to 2. That is the x value. For exactly 2 heads, you have to get 2 heads. If a coin, if a coin tossed, what is the probability of head? What is the probability of tails? Because only two answers we can get. What is the number of times that is the experiment occurred or the trial occurred? 5. X value. What is the probability or the number, exact number, what we want? Exact number of head of 2 times. That is what we want. 2 heads. Now, how can we write this? Remember the rule. P x n comma p. This is the rule. Now, P2, exactly 2 heads. NCX, n is equal to 5 CX2. Then P. What is P? P is what is, we don't know what is P. P2. Okay. Then Q or 1 minus P. Success or failure. So I write Q. Q also n minus x. Sorry, Q to the power n minus x. Just a second, 1 minute. Okay, sorry, I think there is a mistake. Yes, there is a mistake, guys. For this formula, please check the formula again. This will be the formula. I'm writing the power. Okay. That is wrong for my side. You can please write it in that way. Q n minus x, 5 minus 2. That means 5C2 P2 Q3. That is the primary level occur. Primary level portion. Not right, we do fully. That is our questions given. Now we want to solve it. Head 1 by 2, tail also 1 by 2, x exactly 2 head, n is equal to 5. Rules is that any one rule same. NCX PX QN minus X. NCX PX 1 minus Pn minus X. 5C2 P2 Qn minus X. Already done. Now tell me what will be the P and Q. P and Q will be the success and failure probability. Here you toss a coin. Success probability means heads. Failure probability means tails according to our question. Exactly 2 heads. Success probability means heads. So P is equal to here head is equal to 1 by 2. Failure probability also 1 minus P or tail is equal to half. If we do it like that way, it will be P2 5C2 P means half, 2 Q means half, 3. So this is the portion. Now you have to solve it. 5 factorial by 2 factorial into half. Px means p factorial by x factorial into p minus x factorial. Same as this. Qx means q factorial by x factorial into q minus x factorial. To solve it, you can find that thing. The answer is given there. It will be 5 by 16. So this is the answer if you put. Okay. There are also one rule, that is we derived from Bernoulli's trial and binomial trial conjugate, that is n factorial by x factorial into n minus x factorial dot ph dot q into n minus x. You can also use that theory. Little bit of summarize. Can we summarize that thing? Little bit of confusing. Can we repeat? Please tell me in the chat box. Can we repeat? Please tell me in the chat box. Or you can unmute. Okay, I'm repeating again. Just a second. Sending you the attendance link. I'm sending the attendance link in the chat box. In between, you can please fill it up. Okay. Just fill it up, then we start again. Even there will be like confusion. Yes, I know there is a little bit of confusion between changing the theorem in the mid. So I think I would like to formula portion repeating again. Okay. Okay, 1 minus p n minus x, I think, to the power. So half will be there. Half to the power x means 2, 1 by 4 into 1 by 4, 1 by 16 will be there. And then 5 will be capitalized and then 16. Okay, I know now. Okay. So binomial distribution formula. Repeating again from the first. Capital P x n comma small p is equal to n c x p x q n minus x to the power. This will be the formula that we change in the mid portion, and something not changed properly. I'm just recall the things what actually in the happened in the example. So this is the actual formula. You please rectify it. P x n p n c x p to the power x q to the power n minus x. And why or what the terms denote? Small n denotes number of trials. Okay. Small p denotes probability of success. Okay. Q denote probability of failure. Okay. X is the random number. Means what we get the success or failure, that term. Now, as we know, sum of the probabilities will be 1 for a single trial. That means success plus failure is equal to 1. If it is 1, that means P is equal to 1 minus Q, or Q is equal to 1 minus P. Now, the binomial distribution formula can also be written in the form of n Bernoulli's trial. What is the n Bernoulli trial? That is n c x. That means n factorial divided by x factorial into n minus x factorial. This is the Bernoulli's n Bernoulli's trial formula. Okay, this is the binomial distribution formula. Ncx is equal to n factorial by x factorial into n minus x factorial. If we both summarize, both selected, then the new formula will be look like capital P x is equal to small n comma small p, the success ratio, is equal to n factorial divided by x factorial n minus x factorial into p x q 1 minus, sorry, n minus, just a second, n minus x. This is the formula when we summarize Bernoulli's trial and binomial distribution together. Clear? Now clear the formula portion, everyone. Write down in the chat box. Mehul, Gayatri, Venkatesh, those who
Yes,
are
sir.
here. This is the formula portion.
Okay,
Okay.
sir.
Now, what is the questions that are given? We have to find out, suppose 4, exactly 4 heads. We have to find it, exactly 4 heads. So whenever we toss a coin, that means probability of success, H. Here heads we want, that means H is the success. H is equal to half, because only 2 outcome we can get, head or tail. Here we are asked for 4 exact heads. That means success is head. Also failure. How many number of trials? 5. X is equal to exactly 4 heads. Now put in the formula. In fact, capital P, success of heads is 4, is equal to n factorial by x factorial n minus x factorial. 5 factorial by 4 factorial into n minus x, 5 minus 4, 1 factorial. P to the power x means half x 4, q n minus x, half, q means 1 minus p, half n minus x, 5 minus 4. That means 5 factorial by 4 factorial. Okay, so 5 factorials means 5 into 4 factorial. So that is 4 factorial into 1 factorial, half into to the power 4 means 2 to the 4 to the 8 to the 1 by 16. 1 by 16 into half to the power 1 means half. 4 4 is a cutoff. 16 to 32. 5 by 32. Let's check the answer. Okay, so exactly 4 heads. It is exactly 4 heads. Okay, so now we are just getting like if it is asked at least 4 heads, then what is called? It is exactly 4 heads. This is answer 5 by 32. Exactly 2 heads if will be there, then it will be 2, 5 minus 2, then 2 factorial, just like 5 by 16. That is the previous answer. Now, if that is asked exactly, not exactly 4 heads, At least 4 head. At least 4 head. So what is the meaning of at least 4 head? At least means minimum. At most mean maximum. Okay. So removing this thing. This is the answer of exactly 4 heads. Now we are trying to do at least 4 heads. Please read the question very carefully. At least 4 heads. That means minimum 4 heads. That means greater or is equal to 4. Greater or is equal to 4. Now, head or tail. Similarly, like the previous one. Head is equal to half. Tail is equal to half. N is equal to 5. They asked at least 4 heads. So obviously x is equal to 4, one thing. But x greater than 4 also there. So x greater than 4 means there are so many numbers, infinity numbers. But how we can add? We can add also. Because we have to be follow the number of trials 5 times. If there will be at least 4 head, that means 5 time trials happened, at least 4 head. 4 head obviously come in 4 trials. Then one more trial remain. In that trial, it may be it may be head or not be head. I am repeating again. At least 4 head in 5 trials means we last except one trial. It can be first trial, second trial, third trial, fourth trial, fifth trial, whatever trial would be there. Among 5 trials, at least 4 trials should be getting result as head. So the last remaining trial that can be head cannot be head. So they asked at least 4 head. Okay. So at least 4 head means 4 head. If we get exact 4 head, we already performed it. Okay. X is equal to 4. 5 by 32. See, this is the result we have done. Now we have to add with it x greater than 4, because x is equal to 4 we are done. Now x is equal to 4. Here x is equal to 4 means x greater than 4 means x is equal to 5, because only 5 trials are there. If the trial number are greater than 5 means 6 times, and this condition would be there, then we also add this thing. If there will be 7 means greater than 7 trials also there and get at least 4 times head, then we have to calculate x is equal to 7 and add this. But here, as it is 5 trials are there, 4 at least heads, so 4 trials already done, and 4 trial result is 5 by 32 as we performed. Now if x greater than 4 in 5 trials means only one trial is remain, that is x is equal to 5, fifth trial. So what will be the result? P x is equal to 5 means n factorial 5 factorial x factorial 5 factorial n minus x factorial 5 minus x. What is it? 5 0 factorial. Okay. What is the meaning of 0 factorial? Can anyone tell me? No? What is the value of 0 factorial? Yes, 1.
1.
So that thing will be there. P to the power x, half to the power 5. Q to the power x, sorry, q to the power n minus x, half to the power n 5, x 5, 5 minus 5, 0. So 5 factorial divided by 5 factorial into 0 factorial, half to the power 5 means 2 to the 4, to the 8, to the 16, to the 32 into 5 minus 5, 0. Something power 0 means 1. This will be done. 0 factorial means 1. 1 into 1 by 32 into 1. Result is 1 by 32. And you have to add this thing with it. Means when at least 4 head. Exactly 4 head. This is the answer. Exactly. When at least 4 head, then 5 by 32 plus 1 by 32. 6 by 64. Sorry, 6 by 32. Means 3 by 16. 3 by 16 is the answer. At least 4 head. Clear, everyone? Mehul, clear?
Yes, sir.
Okay. Do the example. পড়ে যাচ্ছি। Yes, Mehul. So is sir, if there is suppose n is equal to 100 and once again it is asking to find x greater than 4. Yes, greater than is equal to 4. Okay. Do we have to calculate? Yes, yes, yes. Shorter way. That will be in mathematical terms, but suppose that not be exactly any shorter way in this Bernoulli principle or the things, but just like that means if 100 times will be trial and you have to be get, see now if 100 trials 100 times will be trial there, so minimum 99 or something else or 90, that type of typical answer you can get. Because see in dice also you can throw 10 times or 6 times, the result will be matched. Yes, obviously there suppose need to be some something in formula in mathematics, but not here. Okay, that will be you can discuss or search in Google in mathematical term, that is obviously present. I'm not going that deeper. Okay, I am removing it. Actually, binomial, Gaussian, chi-square, these type of things are so much descriptive knowledge. All distribution are not like that descriptive, because that are mostly used, that are mostly performed in all the statistics. So that's why it little bit sort of descriptive. Now, in computerized Numpy, how it can be done? Okay, as we know, simple things. I'm not uh, extra describe it, but uh, here in Numpy, there is a sort of term you have to write, that is size. Size means the shape of the returned array. Shape of the returned array. When you create some array with the binomial distribution, how many the returned array that you will get as an output, how many values are there, how many numbers are there, how many members are there inside that array, that is called a set. Okay, or you can say that 10 numbers present. Okay, so you can also do it. So that is called the shape of the array. Now see 1 2 3 4 5 6 7 8 9 10. Now let's how we can perform it with the Numpy. There are one more things in Numpy. Binomial distribution is called discrete distribution. What discrete distribution? The distribution is defined as separate set of events. Separate set of events. Okay. So separate set of events means head or tail, not dependency occurs on each other trial. So that is also called discrete distribution. Totally separate. So discrete distribution, head or tails, you can perform. Given 10 trials for each 10 generate data. For Numpy, how we can write? Simply like previous, import Numpy, then from Numpy import random. Okay, from Numpy import random. Then x is equal to normal variable random dot binomial. Then you have to write in the trial number, then success of p 0.5. If there will be like dice here test trial for coin toss, so p is equal to 0.5 because 1 by 2. If there will be like dice throw, then 1 by 6. You have to measure it like that, p is equal to 1 by 6, or in the point number 6, 6 divided 1 divided by 6 means 614.6 again. So that like way you have to be do 0.166 like that you have to do. Okay, this is the probability of success for each trial of the result. Then you have to measure the size, given the size, suppose 10. Then simply print x. Whenever you do it, in every term, it will be changed. See, every turn it will be changed. Okay. Now let's moving to the last topic for today, and binomial style will be completed. That is the how to represent the binomial trial. How to represent in a visualization form. Okay. So same, import Numpy, then import matplotlib dot py plot. Okay. Then obviously write as plt. Then you can write import cbond. Whatever module you can use to visualize, you have to be import. I am not telling that you have to use it using matplotlib or cbond. You can use link, scipy, plotly, whatever you are comfortable, like the modules, visualization module. Okay. Now from Numpy import random. Now visualization configuration SNS first. Then distinct plot, random dot binomial, then is equal to 0.5. Please keep in mind it is not 0.5 every time. Then value obviously not every time it is 0.5 or 10 or whatever the value will be differ. See 1000. Hist for the histogram. We don't need any KD. That is the term for visualize in SNS. Okay. Then obviously plt dot show. See what we find. This is the graph. This is the graph. Okay. Clear everyone? How we can write it? This is the simple thing. This is the visualization thing. Okay. This is the simple thing. This is the visualization thing. Now the next part is difference between binomial distribution and normal distribution. Normal distribution we will do, that is called a Gaussian distribution. Okay, next part or next day. But the main difference is that normal distribution is continuous. Means one trial should be depend upon the another. But otherwise, in the binomial portion is discrete or different, not mentioned each other. Just a second. Okay, so this is the thing. and the other was normal distribution, or you can see the binomial distribution, not more like the difference. It will be like similar way the car, similar way they are going to be performed. The main thing is not in the normal distribution when the trials are happened, it should be the probabilities or the trial result will be depend upon the each trial. But for the binomial distribution, the result that comes, it is discrete, not depending upon the any trial. Okay. So the other way, the visualization portion for the normal distribution and the binomial distribution is like, uh, suppose simple way, if you like SNS dot dist plot, then random dot normal. Then for the normal distribution, there will be like the terms of the variable, where there is n in the binomial and there is L, log, LOC. LOC is equal to 50, like scale is equal to 5, and size obviously is there. Same as random dot binomial. N is equal to number of trials 100. P is equal to probability value of the success. Size obviously what will be. And the respective term is for you, how you can use a histogram or a KD, whatever you want, you can write down in the code. Okay, so this will be the result like PLT dot show. So the result will be like this thing. See, that is a similar. Most of the time things in similar. The main portion is the how the methods comes for the distribution is similarity to each other. What is the gist? Because now not normal distribution is totally dependency occurs, but in the random binomial distribution, no dependency, totally discrete. So that's it. So that is the main difference between these two. Okay. So thank you for today. Thank you. That's it for enough. And like it will be very much long today, very much of totally new things, totally mathematical things will be discussed here. Probability function, probability, how to do that. Okay, so I am giving this notebook. Just a second.
Previous class notebook.
Previous class note I given in the chat box
Uh,
last.
you have been given Numpy distribution in
Um,
previous class.
yes, previous class numpy.
Yeah.
That means the okay, the mean mode median,
Yesterday class
right?
you have been given.
Mean mode median, right?
Yeah.
Okay, okay. That's just
Yes.
okay. I'm not giving it like there will be Gaussian distribution. Okay. So Gaussian distribution is the normal distribution. It will be discussed later. And heading is the Gaussian distribution. Then we discussed about the mean mode median and all the things. So just a second. You just use the mean mode median things and other term. What is the Gaussian distribution? What is it look like? I will be discussed in the next class. Just a second. Gaussian distribution by distribution. Please collect it in the chat box I'm sending. Hope there will be little bit of clearance how the distribution occurs and what the perform. If there will be any issue, we can discuss next class. Thursday morning, it will be 12 or 1:30 or 1. Okay, as similar time. Tuesday. Thank you. One more thing, Mehul, it is done the project. The social media management project done. If it is done, you can submit it in the drive, and Venkatesh, you will be appointed in the next data analysis project. Okay. Next, whatever project will be there, you can add it.
Yeah, okay, sir.
Okay. Thank you. Thank you for everyone. You can leave now. If you completed the code file, Mehul, you can send me in the WhatsApp.